All right, we ready? Okay, so we're going to talk today about using U-substitution with a definite integral, which works similar, but there's a few little nuances. We're going to do a couple of harder ones first, though, okay? So same thing we did yesterday, but we're going to kick it up a notch here, okay? All right, the first thing we're going to do before we integrate is we have to get this to the other side. So we're going to separate that over to the other side, okay? Because technically the dx is supposed to be on the left or on the right side. So I've got dy equals, okay, x minus 4 over the square root of x squared minus 8x plus 1 dx. And it says solve the differential. That means you're going to integrate, okay? That's what the instructions we had at the very beginning of chapter 4, kind of doing that transition from 3 to 4. Okay, let's go ahead. We have, if you had to guess, blindly guess at your u, what would you pick? Yeah, that's an inner function, right? So x squared minus 8x plus 1. All right, let's take the derivative of that. So du equals, what's the derivative of it? And then put the dx after it, right? Because we have to be able to sub in. Here's the thing. 2x minus 8 isn't here. We have an x minus 4. Could I create an x minus 4 out of this? Not multiply by 2. Divide by 2, right? Factor out a 2. Factoring is just division, isn't it? So x minus 4 dx. Okay? So do you see how I have the x minus 4 dx and I don't have that 2? So that's where I know I got to divide that 2 to the other side. Okay? So we have 1/2 du equals x minus 4 dx. All right, I know when I integrate dy, I just get y, right? Okay, so I'm not going to keep writing integral of dy. I'm not ready to integrate the right side yet. All right, for this piece in here, what gets subbed in? U. All right, I always go for my the U sub first, okay? At the same time I'm writing that, aren't I going to convert it to a 1/2 power anyways? So might as well put it in now. Okay? We'll skip one of the steps we did earlier today. All right, for this highlighted part, the 4x minus 4 dx, I'm going to put in the 1/2 du. Good job. I'm putting in 1/2 du. All right. I'm now going to take this, and I got to move it upstairs. How do we move it upstairs? Make what negative? The exponent negative. Good. Okay. All right. We're going to go ahead and do what to this now? Add 1. So we've got u to the 1/2. Divide by 1/2 or multiply by 2 plus c. 2's cancel. So we've got y equals these square. I'm going to switch it back to a square. Could I sub my u back in at this point? Yeah. So x squared minus 8x plus 1 plus c. There's your final answer. It isn't always going to be where it just comes out to be what was on the bottom, right? Yeah. So you got to be careful, all right? You can't just assume that, all right? So there could be something else in there. There could have been another coefficient in there that threw it off. There could, there's other stuff that could go on. All right, let's do one more that has weird. Oh, we haven't done one of these in a while. Check out these instructions. Find an equation for the function that has the given derivative and whose graph passes through the given point, okay? So this is the thing where we have to solve for c. Okay, these instructions mean solve for c, okay? Because we are given a point. Back in the day, you know how they give you the word problems and they give you extra information in there to throw you off? That doesn't happen on the AP Calc test. If you don't use a piece of the information, you have done something wrong in the problem, okay? So if we didn't use this, we would have done something wrong. okay? All right, so embedded in this is our good old U-substitution, okay? What do you think the U is going to be? The pi x. And notice it's embedded in there, and we know when we know we've got a secant tangent, it's kind of together when we do the integral of that one. So U is going to be pi x. So du is going to be what? Pi dx. Which, don't notice the pi is in there, isn't it? Okay, so I'm going to go ahead and throw my integral symbols on there, throw the dx after it here. I'm being a little sloppy about that and lazy about not writing. Okay, I'm going to integrate f prime. That gives me f. All right, we're going to substitute in. So I've got secant, and anytime I see the pi x, I'm going to put a u. Tangent, I'm going to put a u. And then for the pi, notice it's in there, right? For the pi dx, I'm substituting in du, just du. And the pi is going to go away, right? Because it got taken care of with the derivative. All right. When we integrate secant tangent, what do we get? We should have it memorized. Secant u plus c, right? What's the derivative of secant? Secant x tangent x. So the integral of secant tangent is secant, right? They reverse each other. Okay? I'm going to have a way we're going to work on memorizing those better. Okay? I'm going to get you to memorize them. Okay? All right. I'll get it set up over the weekend, and hopefully we'll have it for Monday. Okay? So that you can work on those a little bit better. All right, I'm not done yet, though, right? First of all, I got to put the u back in. So f of x equals, because it looks weird to have f of x equaling something with a u, right? So secant of pi x plus c. But I haven't found the equation for this specific point. This is the general equation. I need to use the point. Remember, this acts like y. So what is the y value of the point? 3. So 3 is going to get substituted in for f of x. What's going to go in for the x? 0. So I've got secant of pi times 0 plus c, which isn't this just 0? Yeah, so the secant of 0, okay, so 0's out here. Secant's the reciprocal of cosine. What do we get for the secant of 0? 1. So what's your c value? 2. And then remember, this is the thing where I've got to sub it back into my equation, right? So f of x equals secant of pi x plus 2. On the AP test, you do some like this on the free response. There's typically one where you have a plus c and you've got to solve for it. So getting usually to this point is the bulk of the points, and then you usually get the final point for being able to do that substitute in. Okay. All right, we're going to learn a shortcut for definite integrals. We ready? Everybody okay? All right. So, do you have to fill in there, or is it given to you? Fill it in. Okay, so fill this in. It's probably just this piece right here, right? I really apologize that it says FU, okay? It's just, it came right out of the book, all right? We would read that as F of you, right? Yeah. We do need to come up with a design pretty quickly here. So, you like that one? We just put like a, yeah, we have to be careful. The tricky part of our AP shirts is, whatchamacallit, you can't have something that can be used on the test on it. So, which is really tricky on ours. So, okay. So what this is saying, okay, basically this is like we said yesterday, this is kind of the reverse of the chain rule, right? That's basically what this is talking about here, is that's the notation for a chain rule, okay? Because, right, there's a function inside of a function, and the derivative of the inner function appears. So what this is saying is, I can do a U-substitution for my G. So up here it says we're going to put U in for the G. So notice to put U in for the G, okay? And then I'm also allowed to evaluate these limits for whatever this is. So I take these numbers and I plug them into the g function and I make those the new limits. What this allows me to do is I don't have to go and put the x back in and then put the numbers in with the x numbers in. Okay, so just watch. It's not as bad as it seems. Okay, so I'm going to start. What is your u going to be? Good. And this is one we wouldn't want to have to expand that cubic and distribute in. It would take us longer. So the U-substitution is a good way to go. All right, so what's du equal to? 2x dx. And do we see that we have... We don't have the 2. Good. We just have the x dx. So I'm going to divide that over. Good. So 1/2 du equals x dx. And you guys, if you need the highlighter for the unit test, that's fine. Use the highlighter. Use a different color if that has helping you. Okay? All right, so let's sub in. I'm going to ignore the limits that are there because we went definite on this one. So I'm going to ignore that for a minute. All right, what's going in for the x squared plus 1? U, and it's cubed. For the x dx, the highlighted part, what are we putting in? 1/2 du. Now let's deal with the limits. Technically, if this always is multiple choice, it's very rarely free response, but technically it's wrong to write those values down because those are x values. And what is our equation now in? U. Okay? So I'm going to evaluate these two spots for u. See how we have a u equation right there? We're going to plug into that. I'm going to show it to you. Eventually, we're going to do it in our heads. Okay? So I've got 0 squared plus 1 is going to be what? 1. So my lower limit becomes 1. Okay? My upper limit, I have to sub a 1 in. So we've got 1 squared plus 1, which is 2. Those are things we could have easily done in our heads, right? Okay. So normally I won't show the work for it. All right. We're going to go ahead and integrate the way we normally would. So we have 1/2. We've got u to the what? Add 1. 4th over 4. And we've got to go from 1 to 2. All right. Could I make it 1/8? 1/8? Sure. Okay. And we're going to go ahead. We've got 2 to the 4th minus 1/8, 1 to the 4th, right? Even though it seems like a good idea to cancel those, is it really? No, because we're going to want the common denominator anyways, right? So what is 2 to the 4th? 16 over 8 minus 1 over 8, which is going to give me what? 15 over 8. So here's what happened. Did we ever take this and put it back in after we integrated? We didn't, like we did on the indefinite, right? Here's why. We changed the limits to u's. If I hadn't changed those limits, I would have had to sub that back in and then use my old limits. Okay? So with this is a nice shortcut. Okay? Because it saves us a couple of lines of work. And typically, it's a less complicated expression. If I had put that back in, it made it way more complicated, right? So it's a nice shortcut. That's the answer, 15/8. You'd get the same thing if you plug this back in and use the 0 to 1 limits. Okay? Correct. Okay? It's the only and you have to remember to convert these guys, right? If you don't remember to do the conversion, and you guys, I know it pops up in the multiple choice. In fact, the multiple choice will just say, they'll give you just this as the answer. They'll say they want to know how you convert it because they want to know that you understand that you can change those limits. Okay? All right, let's try this one.
Do they grade your work for the multiple choice?
No, they don't. Only the free response, the 6 free response questions. Okay, do I grade your work for the multiple choice? No. Just like they do, right? It's how multiple choice works. It's a bubble. All right, let's try this one. What's your u? 2x minus 1. All right, what does that make du? Equals, actually I'm going to put the du over here because this is one of those ugly ones. 2 dx, right? I'm moving it to the right side on purpose. This is one of the weird ones, like we talked about one of these yesterday. The 2 is missing, isn't it? So I have to move over the 1/2. All right, so let's start subbing in, and then you're going to see the necessity of why I wrote it the way I did. This is the same thing as saying I've got to put the u in for the 2x minus 1. Instead of writing a radical, I'm going to write a 1/2 power. Okay. For the, I don't have the x, right? I'm going to have to come back to that. For the dx part, I'm putting in 1/2 du, and I'm going to move this du out a little bit. I'm leaving a little space, okay? Doing that on purpose. All right, remember yesterday how on one of them we solved for that x using the u? We got to do that again on this one. It doesn't happen very often, but it's one of the harder ones, so that's why I'm taking some time to show it to you again. All right, I've got to go ahead and move that 2 over. So I'm going to do u plus 1 divided by 2. Okay, so over here, we're subbing in a u plus 1 divided by 2. Okay, let's finish this algebra and then we'll convert our limits. How does that sound? Okay. All right, so couldn't this 2 get multiplied with this 2 out here? Yeah, so we have 1/2. And then I'm going to choose, see how that's a denominator? I'm going to choose to split it into 2 fractions. Does that sound good? Like we did earlier today? U over u to the 1/2 plus 1 over u to the 1/2. Make sure you understand what I did. It's the same thing as having it over like one big fraction bar. And I split this up into 2 fractions just like we did earlier. Okay? So now I'm going to try to get it to something I can integrate. Because I'm going to go one more line before I do my integration step. So I'm going to switch that to a 2 over 2 because it's just 1, right? So that makes it u to the what? 1/2. And then to bring this upstairs, what do we have to do? Make the exponent negative. Good. All right. Before I integrate, let's convert our limits so we don't forget to do that. Okay, so I need to convert these guys. I'm going to plug them in right here. Does that make sense? Okay. So I'm putting a 1 in there. So we've got u equals 2 times 1 minus 1. What's that? 1. And again, do you have to write that down? It's something you could do in your head. It's our first day at this. I'm writing it down. Okay. Now we're going to now I'm going to put in the 5. 2 times 5 minus 1. 9. Perfect. All right, so I've done that conversion. I'll go to a different ink color. All right, let's go ahead and integrate. So we have 1/2. We're going to get u to the, what? 3/2 divided by 3/2 or multiplied by reciprocal 2/3. Good. I'm going to add 2 over 2 again to this one. So I get u to the 1/2 divided by 1/2 or multiplied by 2. I'm going to go from 1 to 9. I'm going to erase my u's over here, okay? All right. We have to make a choice right now, okay? I can either leave the 1/2 out in front and put the 1 and the 9 in the way it is, okay? Or I can distribute in first and then do the 1 and the 9. How do you guys want to do it? They're both about the same. Okay, so let's distribute. We're going to make the choice to distribute in first, okay? The upside of that is it makes it so it's a less complicated expression eventually. Yes, Caesar?
You know how in the beginning you said you can multiply 2 and 2? Why is it still 1? Oh, yeah.
Oh, thank you. It should have been what? 1/4. Thank you for catching that, Caesar. Good eyes. That was the Friday morning Mrs. Ballard completely forgot. Okay. All right. It happens. All right, so let's go ahead. Let's distribute the 1/4 in. I'm glad we caught it before we started doing this. Let's see. So 2 goes into 4 how many times? 2. So I really have 2 times 3 on the bottom, right? So I've got, that makes it 1/6. U to the 3/2 power. And then again, 2 goes into 4, so that's going to make that one 1/2. I didn't write down the cancel thing. Because if I had written down the cancel thing, I would have possibly kept a 2 there. I did that work in my head. If you have to, write it off to the side, right? 2, right? You have to write it off to the side. Okay, that's the work I did for these in my head. All right, this actually is nicer than it looks, because aren't these square numbers? Yeah, okay, we could probably shortcut this line. I'm not going to, because again, I want to make sure you see all the steps, but in your homework you could shortcut it. So I'm subbing my 9 in, minus big parentheses, I'm subbing my 1 in, plus 1/2, 1 to the 1/2. What's another name for 9? 3 squared. So watch what happens. Magic, yes. Alright. Over here, aren't the 1s just going to go away? Shouldn't it be 1/6 plus 1/2? Okay. I'm going to go to another color here. So why was the 3 squared so important? Yeah, it cancels those nice 2's, right? So let's see, what's 3 cubed? 27 over 6. And then I get 3 over 2, is that right? And then I'm going to go ahead and distribute that negative at the same time. I'm not simplifying yet. Because I'm going to combine like terms and then simplify. Thank you. I'm having issues. At least it's only 2 mistakes so far this morning, so. It's the last example, so it can't get worse, right? All right, 27 minus 1/6 is what? 26 sixths. And then 3/2 minus 1/2 is 2/2. Isn't that just 1? So think about that in sixths, right? Couldn't I make that 6/6? So it's 20 over 6, and whatever that reduces to, what, 10 over 3? Is that right? It's been really noisy this week, hasn't it? Don't these people know they're supposed to be sleeping in? Okay. All right. I did put the assignment up in haiku. Okay. Yes. Yes, change the limits when it's definite. You're gonna think about this. Had we put that back in, if we put that thing back into here, imagine how ugly that would have gotten. And then you have to put these numbers in that weren't pretty numbers, and we got them turned into squares. Okay, yeah. So this is the way to do it. Okay.